welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next big offer. Today, we're going to talk about this Leetcode problem, number of islands. As a matter of fact, this problem I talked about back in 2015, which is 5 years ago. Thanks a lot for all the comments. I replied all of your comments. I apologize. Some of the comments are actually 4 years overdue, but and also I could definitely improve more on the explanation part of the video, because at that time, I think I was more like coding while I was explaining versus I could just explain. So for this particular problem, I think, I will link the video in the description and feel free to take a look. But more importantly, the gist of the previous problem is whenever we see a 1, which is a land, we should trigger a BFS and a DFS to mark all the other connected nodes or grids. And then we increase the island count by 1. But today I want to more like introduce you another data structure or algorithm. The data structure is called the disjoint set and the algorithm is called the union find. It's essentially people use it interchangeably, meaning the same thing. But it's a very powerful data structure that we can use it to solve problems like, giving you a phone context, A knows B, B knows C, how many groups are isolated groups are there in the context or in the graph. I think that would be more useful to solve this problem in literally BFS, DFS, and the union find disjoint set way instead of doing more problems. Okay, so what is a union find or disjoint data structure? So it is actually quite simple. All we need to do is for each of the node, we need to maintain a mapping. So let's say this is a node. What is the parent of this node? So for example, in this undirected graph, right? So if you have 0 and 1, first we're gonna look through the neighbors. So we're gonna initialize the graph to be all of the nodes, the parent is gonna be itself, like 5 and 6. And then while you are traversing through this graph using the either the adjacency matrix or adjacency list, you're going to mark the parent. So for example, this, the parent is 0. And then for this 2, the parent is actually 0. And then once now you are at 2, you're going to mark 3 and 4. So the 3, the parent is 2. But the 2's parent, is 0, right? And 0's parent is 0, which means this is actually the absolute root node. And then for 4, the parent is 2, so you upload this to 2, and also 2's parent is 0, and then 0's parent is 0. So all those are actually connected. As you can see, so there's actually, I listed here, so there's a different kind of algorithms. So to detect for an undirected graph whether it has circles or not, we can actually use union find with edge list graph representation, which means we go over every edge, right? And then once we are on this edge, we will for every edge, we will check whether they share the same root or not, parent. But on this edge, we know, 3 you share, and 4 they actually share the same parent, which is 0. So now this graph has a cycle. So if we continue with this graph, you can see 5 and 6. 6, the root is actually 5. Oops. And then wow. Apologize. So this graph essentially has 2 isolated graphs, right? One is the green one, the root is 5, this one, and the other is the blue one. Okay, so back to the original problem. How do we solve this problem using union find? So I have actually my code here. Just give it a sec. I think my computer laptop is overheated right now. Okay, so this is the code. The idea, if I would do it, is actually quite simple. So what I do is for each of the index, right, you have row and column. I just put a comma in between as a key. So I initialize the union find data structure or disjoint data structure. And then I will just basically mark parent, right? So the idea is, so for all the ones, as long as it's 1, so you will essentially group all of this as one parent, and then this is another parent. So this is the first iteration. And the second iteration is you go through the array and then you go through the matrix, and then you will find how many distinct parents are there. So to implement a disjoint set, essentially you need to implement two methods. One is find, the other is union. And the way to implement this is you keep this hash map as your mapping. So the key is the current node and the value is the parent node. So first thing we need to do, as you can see here, is initialize the map. So the parent is always itself. And then whenever you do a union, what you will do is you will find the key, the first key, the actual root parent, and then the second parent of the second key. And then if they already belong to the same group, you don't need to do anything. But if they belong to the same, they don't belong to the same parent, now you need to connect these two together by, I always do parent 1, parent 2, doesn't matter. You can do 2 and 3, it's all the same thing. It will just all work out fine. And then whenever you find, you can, as long as it is not pointing to itself, you need to find the true parent, right? And then you just keep looping this, and then you will find the true parent key. There's another way to implement this find is, as you can see here, right? So you can compress the path is, so 2's parent is 0, 3's parent is actually 2, and 2's parent is 0. So what you need to do, you can update 3 and 4 to be all 0, which essentially means whenever you are trying to find the path, you have to do this extra step. You can Wikipedia the algorithm, but you just keep updating all the nodes to the actual absolute root parent. So given this algorithm, so the code is relatively straightforward. So you implement this disjoint data structure, you initialize, you have find a union method. So what you're gonna do for this problem is, you instantiate a class of disjoint set, and then for every key, explore to the right grid and also to the grid below. So essentially for every one, I explore the right one if they are 1, and the bottom one if they are 1. So after this, if they're all 1, so I'm gonna connect this together. So now they all belong together. And then in the second iteration, so I have a hash set. I have a hash set, and then I'll just check how many distinct parents are there by using the find, because find can always find the root parent, and then I'll return the size. So one thing, just to show it to you more like graphically what this means is, so now if I have a node 0 and 1, right? So 0 and 1, previously they all the parent point to themselves. 0, 1 is 0, 1, 0, 2 is 0, 2, and 1, 1 is 1, 1. So now what I mean is now 0, 1 actually points to the node, the parent is 0, 2. So now this is the right part, and then the below part, the 1, 1 is also a 1, right? It's also a len. So now we need to connect. So just keep in mind, so now it's not you're pointing 0, 1 to 1, 1, because 0, 1 point to 0, 2, 0, 2 point to 0, 2. So now essentially you're gonna connect 0, 2 is gonna connect to 1, 1. Right. So now, as you can see, for this node, the parent 0, 1 is 0, 2. 0, 2's parent is 1, 1. So essentially with this kind of ordering, all of those, their root parent is actually 1, 1, based on my implementation. But you can also totally reverse. If you reverse this part, if you reverse the code from parent 1 to parent 2, so if you do parent 2 first and then parent 1, and then it will be the original one, but it doesn't really matter, like I said. Okay, just give it a try, and then I really suggest everyone to understand union find algorithm / data disjoint set data structure, because it's so useful for you to do any kind of direct graph, A knows B, B knows C, like how many distinguished groups are there, given a person, another person, do they know each other or not? Those kind of problems. It's very simple. Okay. All right. Thanks a lot for watching. Feel free to leave any comments. I'll see you guys next time.